So in this question, we're told that by considering the algebraic expression given, we have to factorize 82,896, okay? And we are told some information about 82,896 in terms of things that look very much like the algebraic expression the question has asked us to consider, okay? So let's see how we could do this. So the first thing we want to do is actually simplify this algebraic expression in the hope that the right-hand side would give us some factors, allowing us a way to factorize the number much more easily. So let's see. So we want to write a plus b to the 4. Now, prior to A-level, you would just expand this out the long way, but obviously in A-level, we used the binomial theorem, and the easier version of it is to be able to use Pascal's triangle. So if you're unfamiliar with this, then please go back, look at a previous video where I have talked about this in some detail. But basically, for our purposes, we know that this row here corresponds to the coefficients of my power 4 expansion. So I'm going to write that down. So I know that a plus b to the 4, whatever it is, the numbers in front are going to be 1, 4, 6, 4, 1. And then I'm just going to write down the first number in my brackets that I'm expanding. In this case happens to be a, so I'm going to write a in front of each of my coefficients. And I'm going to repeat this for b. So now I've got b in front of each of my coefficients. And now the only thing that's left is actually putting appropriate powers on the a's and the b's. So we're going to start with the a's, which is we take the power, the highest power that we're trying to expand into, and we have that as a starting power on our a term, and then we reduce it by 1 for each successive term. Okay, for each successive a, it's going down by 1. So that's that, and then we repeat this for b, but we've got to be careful that we actually start with 0 on the b and then increase the power 1 at a time. Okay, so you can see that happening here. And a quick check is the powers should sum to give me the power that I'm expanding. So 4 plus 0 is indeed 4, 3 plus 1 is again 4, 2 plus 2 is 4, 1 plus 3 is 4, and lastly 0 plus 4 is 4. So this seems sensible. And the jump from here to here is nothing more than just really simplifying, okay? So a to the 4 is just a to the 4, but b to the 0 is 1, so we don't write any b's here. I will leave you to check the details of this, but this is fairly standard, okay? So in other words, we've worked out what a plus b to the 4 is, and actually we need to work out a minus b to the 4 as well. So we could redo all of this process here, but actually we can be smarter, and what we can say is the only thing that's going to happen is it's going to be the same formula as the one I've already worked out, but rather than having b's in the brackets above, I'm going to have minus b's instead, because I've got a minus b in place of plus b, okay? And if you think through what's going to happen in that case, then everywhere where b has an even power, the negative is going to die. And everywhere where b has an odd power, we're going to get a negative. So in other words, the only terms that are going to be different is going to be b to the power 1 and b to the power 3. So you see these two expressions are exactly the same. The difference is there are sign differences where b has odd powers. So we've figured out two expressions fairly nicely, and now we need to take them away. So we do just that. We take away the top one from the bottom one, and we see that the a to the 4 terms are going to cancel, the 6a squared b squared terms are going to cancel, and the b to the 4 terms are going to cancel. And the only terms that don't cancel are the a cubed b term and the ab cubed term. And actually, because of the symmetry in these two expressions, they're pretty much the same size with a different sign, but I'm taking them away, so I'm just going to get two lots of them. Okay? If you're unsure of what I've said, then perhaps the only thing you need to do is just do the algebra. Literally do a subtraction of these, and you'll find that the thing you'll get is what I have here. So this is quite nice because it's in a factorized form, but actually I see that there's a 4a that I can factorize from here and a b because I have a 4ab here. So we can simplify this further, and when we factorize this, we can take an ab out and a 4 out. We'll get a 8ab because I already had a 2 at the beginning, and then the term inside the bracket is going to be a squared b squared. So now notice that on the left hand side I've got something which is a difference of powers of 4, and on the right hand side I have something which is factorized, which is very much like the sort of thing we were hoping for. So I'm going to write down the information the question tells us. The question tells us that the number we want to factorize fully can be written in this form, which is 17 to the 4 minus 5 to the 4. So if I just match these up, so in other words, if I say that this thing here, I want to be like a plus b to the 4 take away a minus b to the 4, then I can say, well, okay, that can be arranged because the powers are already allowing for that. And the sign is already allowing for that. So the only thing I need to do is I need to make my a plus b to be 17, which is this equation here. And I need to make my a minus b to be 5, which is this equation here. Notice we don't say a minus b is minus 5. It is positive 5. And that's because the minus is on the outside of my term. And that minus is also on the outside of my term here. So the a minus b should just be 5 itself, okay? Well, now we've got a pair of simultaneous equations which we need to solve to figure out what a and b are, and we can do this quite easily. We just add them up, and the positive b and the negative b are going to cancel. The two a's are going to be summed to give me 2a. 17 plus 5 is 22. So I divide both sides by 2, which gives me a is 11. And if a is 11, what do I have to add to 11 to get 17? Well, it's certainly 6, okay? And we can check here, 11 minus 6 is indeed 5. So a and b actually work. And so we can use the formula we've worked out here, okay? So we know that this was the left-hand side of our formula, and we figured out a and b so that we could use the right-hand side of the formula. So in other words, this number that we've got can be written in terms of this, where I know my a is 11 and my b is 6. So it's going to be 8 times 11, which is a, times 6, which is b, or times by a squared, which is 11 squared, plus b squared, which is 6 squared. And so our task of factorizing is so much easier now because we just have to factorize any of these factors further. Okay, so let's see what we can do. The 8 is 2 cubed. 11 is prime, so we leave it alone. The 6 can be expressed as 2 times 3. And the 11 squared plus 6 squared, well, we just work these out. That's 121, and that's 36. So when we add that up, we get 157. And you could be forgiven for this, but 157 turns out to be prime, which means we just leave it alone. That's going to be a pure factor. The 2 can be combined with 2 to the 3 to give me 2 to the 4. And of course, the 3 and the 11 are prime, so we just have them separately, which means we actually have managed to figure out a complete factorization of the huge number we started with. Okay, so we've answered the question. I hope this has been useful. If it has been useful, then do consider subscribing.